Hi everyone, I am Jay Krishna from AAA department. Today my topic name is HPLC chromatography. Subject name is chemistry. Subject code 23CHG01. HPLC chromatography has been largely been supplanted by much more powerful analytical chromatographic technique which allows the chromatographic separations and trace level analysis of a variety of in a short time. In principle, any chromatographic technique of analyzes an isolated compound from the mixture of compounds eventually separate as a result of an interaction of the individual analyte with the stationary phase and mobile phase. The separation of analytes from a mixture is due to column based affinity with the mobile phase. So if the mixture or samples are different polarities, one component will migrate through the column faster than the other. These differences allow the mixture of compounds to be separated from each other. By using these differences to determine transit time and retention time of the solutes through the column. And next one, instrumentation. The following major components are required to the functioning of the HPLC. A solvent reservoir to store the mobile phase. High pressure pump to push the mobile phase through the column. A device to inject the sample into the mobile phase. A column in which the separation will take place. A detector using to detecting the concentration of the sample components as the come out of the column. Next slide. This is the diagram of the principle of liquid chromatography. So many load sample, add solvent, the so many items. For the analysis of thermally stable volatile or the inorganic compounded via a separation procedure in gas chromatography, the method of sample person involves as the synchronized port located at the head of flash vaporizer pour column and separated analytes how liquid of grace chromatographic column whose response duplicated on a computer action of the sample may be made manually of using an auto sampler. Election is about my face William Trojan and the type of used mobile phase does not hydrogen. The flow of an mud gases mobile. The choice of gases is often dictated by its contrast to most other types of chromatography. They interact with molecules, gas systems. The most column mobile phases for GC are helium, nitrogen and hydrogen, which have the advantage of being chemically next inert. The choice of gases is often dictated by the type of detector used. The gases of injectors, several capillary injectors are available. The most common of which is a split planeless injector. The injection takes place into a heated glass or quartz, linear rather than directly onto the column. In the split mode, the sample is split into two unequal portions, the smaller of which goes on the column. This technique is used with concentrated samples. In the splitless mode, the entire sample is introduced onto column. Column. Column is a two general types of columns are encountered in gas chromatography. Packed and capillary columns are made from fused silica, usually coated on the outside with polyamide. This is the diagram of chromatography. So many parts are there. And next one, detectors. As solutes evolve from the column, they interact with the detector. The detector converts this interaction into an electric signal that is sent to the data system. The magnitude of the signal is plotted versus time from the from from the injection, and a chromatogram is generated. Some detectors respond any solute eloping from the column, while others respond only to solutes with a specific structures, functional groups or atoms. Detectors that exhibit an enhanced response to specific types of solutes are called selective. This is the detectors. Flame ionization detector. One of the detector. Nitrogen phosphorus detector. Second type of detector. Electron capture detector. Another one, thermal conductivity detector. TCD. Flame photometry detector. FPD. Mass photoionization detector spectrometer. MS. This is the chromatography. And finally, thank you.